Welcome to UHS MDCAT Physics, and this time we'll be doing questions primarily from the Part 1 book, and this video is made specifically for A-level students to sort of familiarize themselves with the subject content and the differences and the similarities between A-levels and physics. For those of you who are preparing in MDCAT, let's proceed. This question ought to be familiar. In S is equal to AT plus BT plus CD square, S is measured in meters and T is measured in seconds. So what is the unit of C? You have to realize that when we're adding stuff up to form a value, so the total value and each individual unit that is being added together ought to have the same unit. And because we know S is in meters and we know this is simply seconds, so it's S square, and so C should have a unit such that in total the total CT square has a value of meters. So if C had this value, this would have cancelled out and we would have been left as a meter as an overall value. So the answer is A. So a lift is going up. The variation in the speed of the lift is as given in the graph. So this is velocity and time graph, I believe. So what is the height to which the lift takes the passengers? Well, initially we're observing that the velocity is increasing at a certain point and then it becomes stagnant, and what that means is that so the velocity increases till a certain value and then it begins to fall and then it becomes constant and then it begins to sort of decrease. Now you would be like, this is decreasing, so what does that imply in this scenario? Till which point ought we take the area under the graph? Well, the reality is you have to take all of this because this is velocity is a vector. Had the lift at any point stopped and begun going down again, the velocity sign would have inverted such that it would have now been in this axis. The fact that there's been no inversion means that all of this denotes distance traveled in the positive direction. This is a mistake I think people make. So if we take this into account, we can do this separately. 2 into 3.6 divided by 2, so that's just 3.6. 10 minus 2 is 8, and this time it's 8 into 3.6. 36 into 10 for ease, and over here it's still 3.6, but whatever value it is, it's a bit less than 2. But anyways, we can estimate it as being almost 2. Now you can solve this. 8 into 36 over 10. 4s are 8, 2 5s are 10, 5 7s are 35, 7.2. 7.2 into 4, 4 2s are 8, 7 4s are 28, 28.8. And if you add what is 3.6 and 3.6, it's about 7.2. 28.8 plus 7.2. The answer is about exactly 36 meters. But one wonders, if if it should be exactly 36, it shouldn't be. It's ought to be a bit less than 36, but not by a huge amount. But 28.8 is way too big, so the answer ought to be 36 meters. Let me review the methods. This is a triangle, so it's 2 into 3.6 divided by 2, which leaves 3.6. Then minus 2, 8 into 3.6, or 8 into 36 by 10. .8 is fairly easy to get. 28.8 is fairly easy to get. You just have to add 3.6 into 3.6 into it, which leaves about 7.2. One of the more tricky questions in my opinion. So body of mass mkg is lifted by a man to a height of 1 meter in 30 seconds. And another man lifts the same mass to the same height in 60 seconds. So what is the ratio in which they did the work? The ratio is 1 to 1. The reason being that time has no involvement with work. Had this been about power, the answers would have been different. A player completes a circular path of radius r in 40 seconds. So there is a circular path. Its radius is given. The time taken for him to reach the same point is 40. So what is his displacement at the end of 2 minutes 20 seconds? So let's convert this into minutes to seconds. 2 minutes is basically 2 into 60 is 120. Plus 20 makes 140. So 40. In the first 40 minutes he completed one cycle, and in the next 40 he was back again. Another 40 and he was back again. So that is 120. And so if you're assuming that his speed is uniform, 20 seconds later he ought to have been somewhere in the middle. So if he started at one point, he would have reached the diametrically opposite point. So what would have been the displacement? The displacement is a straight path distance. Oh my god, that is a pathetic circle. So you would have basically reached the halfway point over here, and because displacement is a straight line distance, it would have been equivalent to 2r, because r is the radius. Right, and the displacement time graph shown in the figure represents the displacement is increasing at a constant rate. That implies that we have a constant velocity. The velocity of the body is continuously changing. False instantaneous velocity, likely not, because that would be for one particular instant. The body travels with constant speed up to time t1, then stops. Yes, zero displacement implies there is zero velocity. There isn't any movement at all. Constant velocity, no velocity at all. That is zero velocity, because displacement is constant. In near optic fiber system, what is the distance between two repeaters? I think it's about 100 kilometers. But truthfully, I kind of forgot about this too. So this is, for those of you unaware, this is from the physical optics, I think, or maybe it's optical instruments. Anyways, there's a lot of stuff to memorize from that particular topic. It's one of those theory heavy topics from physics, and it also includes you to have some knowledge of optical fibers, which is the last topic. Yes, so repeaters are typically placed about 30 kilometers apart, but in the newer systems they may be separated by as much as 100 kilometers. Now this is important. So typically 30, but because over time we have developed newer systems, we can increase the distance for which a repeater is needed. There are other stuff you need to remember from this topic. Mainly you can skip the rest of the topic in terms of theory and go on to fiber optic principles, and here are a couple of formulas that are really important. Let's talk about those at the end of the video. So the direction of torque in earth is anti-clockwise, clockwise. Along the axis of the torque, it has no torque. Torque is a strange principle. It's when we have a force that is perpendicular to an axis, right? And there is this pivot point, I guess, and because there is this particular force acting on it, like if we have this lever point, and we like apply a force like this, because this force is sort of like perpendicular to this radius from a certain point, which is kind of like fixed. If we can assume something is fixed in the first place, we will expect there to be something of the sort. We know that the earth is moving. And so that would imply that there is this torque with reference to the center. What is the direction? Well, the answer can be found in the circular motion topic, primarily in where they've talked about satellites, and you have to be really careful with the geostationary topic, because that is again one of the more theory heavy topics. They are often asked questions from it. The rest of the topic is more conceptual than anything else, and also you have to take a look at orbital velocity. So the geostationary orbit is from 120. So we know that geostationary orbit is an interesting and useful example of satellite motion. And its motion is synchronized with the rotation of the earth, such that it remains over the same point on the equator as the earth spins about its axis. It is useful for worldwide communication, weather observations, navigation, and military uses. I don't think it's actually written anywhere over here. But yes, in figure 5.20, it would appear that the motion is clockwise. There's this diagram which would suggest that the motion is clockwise. I don't think it's actually written anywhere, but it's drawn in such a manner. But another diagram, it appears to be anti-clockwise. Yes, it's anti-clockwise, my bad. Now that I've looked at it, the motion of both the earth and the geostationary orbits that cover it is anti-clockwise. And this is from diagram on page 122. So what we've learned so far is that theory is really important in FSA, like in A-levels, so we have to remember stuff like this. Sadly, not part of the syllabus anymore. So blue shift in light means the source of light. Blue shift is the one with the higher frequency and the low wavelength, and what that means is that something is approaching you. You cannot see through the corners but can hear through the corners, because obviously sound diffracts considerably more than light. So temperature, which is the same in the degree Celsius and in the Fahrenheit. Like some people actually remember this, but there is a way of figuring it out. So how do we convert from one to the other? We have a formula, thankfully. Right, so this is how you kind of like convert from one point to another. So it needs to be negative, obviously, and it needs to be such a negative value that this point over here and this point over here are the same. Like f is equal to, so we can make basically both of these, we can take these to be x. Over here we will have 9 over 5x plus 32. So it can be minus 32 on the other hand, and it will be 4 over 5x on one side, and it will be minus 32 into 5 over 4, that will be equal to x. So 4 ones are 1, 4 8s are 32, the answer is minus 40. Let me show you how that works. Now some people actually remember this shit, and yep, we could, but there's already so much stuff that there isn't any way of working out ourselves, so I would suggest you stick with whatever suits you. Minus x, so 4 over 5x is equal to minus 32, and I'm sure you can do the rest of it yourself. Right, anyways, we have the next question, which is about YDSC, which is frankly one of the topics I really like, because it's mostly the same as an A levels, just less interesting. If YDSC arrangement is shifted in water, then the first maxima will be formed at an angle of